questions, I think there may be more mistakes. I will slow down. Otherwise, I will go relatively quickly because I think most people did pretty well. And some of the questions are actually in the assignment or in a handout. Okay? So for the first question, we ask you to write function about string. This should be pretty close to the assignment. You want to see whether the string reaches the special function. Some people check whether the string is null, and that's great. But we didn't take points out if you don't do that. Then you will count until the string reaches the null character, the ending character, right? It's already written here, but it does not include. And another mistake here, some people after they get out, they add one more. That's a mistake. It's already said in the requirement, do not include the null character. So don't increment. You can either do this. So many people seem to still have a confusion about the types. This is if str is character star, then str star str is character. Right? If you read the class note, you should understand that. And then strlen is also char. Every time you add one star, you remove one in front of str, you remove one star in the type. So if str is character star, star str is character. If you are not sure what I'm talking about, go to read the class handout. I'm going to remind you. I'm waiting for that to load. Okay. So if you look at pointers, there should be a table. Okay, this is the table, right? PTR is a pointer, that means it stores an address. When you do star PTR, notice the difference between 1 and 3 is there's a type in front, integer in front, right? So number 1, you have a type, integer or character or something else. That says PTR is a pointer. And number 3 or number 4, there's no type. Therefore, you are not creating a type. You are using a pointer. And after you create a pointer, you use either number 3 or number 4. You get the type itself because you read from you get the address and you read from the address. Therefore, star str is a character. It's no longer a pointer. An array is always a pointer, and if you take one dimension out, you get a character. So some people have confusion. They use star str len. This is a syntax error because str is a pointer, len adds one dimension index, that becomes a character. Once it becomes a character, you can no longer add a star because this is a character, this is not a pointer. Some people did return str, that's also wrong type. Str is a character star. Here, size of t is an integer. Okay, any questions about this? So the second question asks you to allocate necessary space. So you should do the following. You should do char. You can say string 2 is malloc. You need to add 1 for that character. We emphasize quite a few times. Also, if you read the class note, you have to add 1. Then you will write something like the following. You need to include the last ending character. Again, because string length does not include that ending character. If you don't have the equal sign here, you are not going to include that one. And then here you should say return str2. Common mistake. Many people free str2 in the middle. I'm not sure why. Maybe 10 people did that. If you're free, what are you doing? You basically allocate memory, you release the memory, you're not doing anything, right? Another mistake is some people actually do return str2. Again, that's a type mistake. str2, this is a character, since you add a star in front. And another common mistake is forget to end str2 using, these are 3 common mistakes. Any questions? So the next question asks you to change to lowercase later. Notice that there's no constant in front, means you are going to change it. And I think this also says here, all uppercase letters should be changed to lowercase. Do not apply to numbers or symbols, including white space. So this is what you should do. Now, whether you have equal sign here or not doesn't really matter, since if your equal sign, that simply means you are going to count the ending character. Since the ending character is not an uppercase letter, so you should not make any change, right? So here you will say str. Now this is something majority of people make that mistake, and I will tell you again and again. If I have to, I will tell you again. Do not use 65. Do not use 65. Majority of people use 65, and that's an invitation of mistakes. And many people use 64. I did not take points out of if you do 65, but if you use 64, I took points, because obviously that's a mistake. You should not try to remember the numbers. You should use symbols. So this means str is greater than capital letter A or less than capital letter Z. Majority of people use 90. You should not. Now I don't know how many times I have to emphasize. Do not use 65. Okay. Is that enough? Next time, if this happens again, I will take point. Okay. Why? Because that's an invitation mistakes. I will say that many times. I want you to understand how to avoid mistakes. Many people use 64. I don't know why. And many people use 89. They just misread by 1. If you use symbols, it doesn't matter if it's 65 or 60. Compiler will take care of it. Okay. So I will take points out next time if you use 65. Okay. So you'll say str. This means str ind is between capital letter A and the lowercase z. So strind will be strind minus, you look at the distance. Do not use 98. 98 is this one. The correct difference is, okay, is 32. Some people, common mistake is, many people write 20. 20 is hexadecimal. You have to write 20. If you simply write 20, that's a mistake. Some people did not check. So they always add everything by 32. That's also a mistake. Because it's already said in the requirement, you only convert uppercase later. If you do not check, you convert everything by 32. You add everything by 32. Another common mistake, and I don't know why, many people return. And a few people also free str. So that's another mistake. Not very common, a few people. Okay, any questions about this? Okay. Alright, for next question, I'm going to go over by drawing, since it's hard to draw in computer. Okay. So, first, you have 42 and a 9. So you print, this one will be 42 and a 9. I don't think there will be any question. You call this function, A is 42, B is 9. But inside you swap them, so this one will be 9 and the 42. So this one will print 9 and the 42. However, this is not addressed. So it's a copy. Once the function returns, swap one returns, x, y are not changed. So it's still 42 and 9. Any questions about that? As I said, swap function is used so often, you should know it very, very well. The next is x is 42, y is 9. You give the address. So this is a standard way of calling swap function. Inside A star A is 42 when you enter the function. Is 9. Then T is 42. And this line makes star A is 9. Star B is 42. So inside your print star A, so this one will be 42 and a 9. Alright, we just did that. And star A, inside your print, star A will be 9, star B will be 42. This is a standard correct way of calling swap function. And when the function return, this will be 9 and 42. Any questions about this? Okay. The following are a little bit more, needs more work. So I'm going to put the swap function aside. Okay. So here it says Z. I'm going to draw the call stack. Z, W, Z is 77, W is 33, and then we actually tell you the address here. So P and a Q. P is a pointer. P's value is Z's address. So whatever address is here, it's going to assign here. And then we tell you P's value is C4, so I'm going to put C4 here. You see that? This happens because I say P is a pointer. This line means I create a pointer. and P is the address, P is the value is the address of Z. This line means these two lines. Then, based on the information given to you, P's value is C4, and Q's value is C0. So this will be C4, this will be C0. And P and Q themselves also have the address. So for simplicity, I'm going to write 100. I'm going to write 104 here. Any question why I have this so far? Okay. So it's a print star P and star Q. Star P, P's value is C4. Star P means take the value from that address. So this one will be 77. Q will be 33. Okay? Any question? I'm going to fold this so I can put more things. Since I don't need the AB in that part anymore. Okay? So this is what I have so far. Then I'm going to call swap 2. Okay, so you have a return location. I'm going to skip that. So I have A and B in swap 2. A and B are pointers. So A and B have their own address. That means simply write 200. That says 204. Swap 2 is pointer A and B. So C calls a function caused by variables. So you copy the variable. So this will be C4. This will be C0. You copy the variable. So that's how I get to swap 2. Okay. Swap 2, I have temp. Temp's value is star A. So I take A's value as an address, go to read the value at the address, temp will be 77. Star A equal to star B. Star A, A's value is a C4. So I'm going to modify the value as C4. Star B is C0, so this will become 33. And then the next line says star B is to temp. Star B is B's value is C0. I go to modify this one, becomes 77. So when I print, inside the function I print star A, A's value is C4, C4's value is 33. B's value is 77. Star B's value is 77. Any question? Okay. So here I will print 33, 77. Then I don't print right after this swap. I go to say Z equals 77. So that means I change this back to 77 again. Because of this line, line 46. Line 46 says change this to 77. W, actually, that's not what I would write it. I would write with semicolon. And change W to 33, so I change W to 33. Then you print. You print star P. Star P, P is still C4. Right, so here I can still write C4. I haven't changed P yet. And Q is still C0, right? And star P, C4, it goes to C4, so this is 77, this is 33. Why? Because line 46, change it back. Any question? Okay, so we are done with line 47. Okay. Then of course, after we get our swap 2, this is gone, right? So let me redraw the call stack just to clean up. ZW, this is C4, C0 is 77, 33, PQ, let's say this is 100, is 104, C4, C0. So I'm redrawing the call stack when after finish line 47. Now I call swap 3. Swap 3 again has A and B. Now swap 3 is actually pointer to pointer. So suppose swap A, B have their own address. That means 200 here, 204. We call swap 3 use the address of a P, so this will be 100. And this will be 104. Because I'm giving the address and the P and the Q. Then temp is a pointer. Let me say 208. So temp is a pointer, and temp's value is A's, the value from A's address, A's value. This means I take A's value is 100, and I go to read that value at that 100, so temp's value is going to be C4. This means integer, temp, and temp equal to star A. Star A means take S value as an address, read the value at the address. S value is 100. So I go to 100, read the value, that's C4, so temp is C4. Then star A equal to star B. Star A is 100. Star B is 104, so I read from 104. So that means I change this to C0. B's value is 104. Star B is the value at address 104. Now the value at address 104 is C0. And star A's value is 100. It's on the left hand side. So I modify the value at address 100. So this becomes C4. And then star B is equal to temp. So B is 104. You modify this, and so this becomes C4. I'm not modifying A. I'm not modifying B. I'm modifying star A or star B. So you need to know which one you are modifying. So I take A's. Star A means I read the S value as an address, go to that address, and read that value as an address again, and read that value. So star A is 100. I go to 100 and read. This becomes C0. So this will be 33. Take 100, go to 100, go to C0, so I read the value as C0, so that's 33. And this one will be 77 because maybe I should clarify this again. Star A means you can think of this way. You add a parenthesis. So this means take S value as an address and read the value at that address. So take S value as address 100, read the value at that address, so I get C0. So this part is C0. C0 is still address, so you add one more star. You go to C0 and read the value. Therefore, you go to C0, read the value is 33. And last look at P and Q. P is 100. Star P, go to C0, read, that's going to be 33. because P's value is C0, so I read the value from C0. And stop Q will be 77. And P currently is going to be C0 because I have swapped them. Q is going to be C4. Z and W have not been changed. So this will be 77. It will be 33. For this question, there are 18 blanks for you to fill. And I run it up to 20. So for each mistake, you lose, it's 5 points total, so you lose 0.25. That means everybody gets 0.5 for free. I think that's just easy to calculate. Okay. I assume there's no objection, getting 0.5 points for free. Majority of people did this somehow right. I don't think anybody got below 2, I think. I think majority of people got at least 2. But everybody made at least one mistake here. You didn't? Okay. But the high score is 19, so you got a mistake somewhere else. The high score is 19.5. Okay. All right? Okay, good. You got it right. Any other questions? Okay, you have to practice again and again. All right, so the next question is actually from class note as well as from the assignment. So for the integer comparison, first, why do you need to have constant void star? That's what C requires. If you don't give that, you get a compiler error. So you should do the following. First, you should change it to cast. I will talk about some common mistakes in a moment. You have to cast. You can try. If you don't cast, you get compiler error. So a few people wrote this. They try to make it fast, but that doesn't work. Because you have to cast. Without casting, compiler doesn't know how to compare them. Okay. For sort, so you should say Q sort. You can give numbers. I actually don't remember the order, but we did give to you next page. The next one is the number of elements. So you should say length, size of int, and then you say int compare. Or some people do slightly different. They give. That's fine. Either is fine. Mistake is swap length and you cannot swap them because the second argument says how many elements you have, and not the number of elements is not the number of bytes for integer, so you cannot swap them. Another mistake is to return anything. Some people will say return numbers. You cannot return numbers because this function is void. So you cannot return. Okay. So this was in assignment, so I assume most people got it right, except some small mistakes. Forget to cast and so on. Okay, the next question is Fibonacci number. We asked you to find 2 bugs here. So first, a few people say you should not add 1. That's actually there's no mistake. Add 1 is correct because you want to calculate to n. If you don't have add 1 here, you cannot have n. So this is not a mistake. N plus 1 is not a mistake. The mistake is here, you need to change to 2. Why? Because if you start from 0, this will be minus 2. Minus 2 is not a valid index. So you should start from 0. That's the first mistake. Second mistake, you cannot free and return. Because once you free, buffer N no longer exists. So the correct way to do it is you have an integer, let's say temp. That's a correct answer. A few common mistakes. First common mistake is some people say move line 19 after line 20. Why is that a mistake? Can I get it? Because once you have a return, anything after return will not happen. So that doesn't help. Okay. Another another common mistake. This is pretty surprising. Maybe about 10 people they want to free start buffer. This is simply a syntax error. Then a few people also did that. They say, okay, I understand if I free here, I cannot return. So they simply say delete line 19. So what's wrong with that?
Memory leak.
What?
Memory leak.
Memory leak. Why?
Didn't free the buffer.
Because it didn't free the buffer, and since there's no way after the function return, there's no way to get up memory location anymore. Buffer is a local variable, so once the function returns, that local variable is gone because that's in the call stack. So you don't have a way to hold on to that piece of memory anymore. That's another mistake. Any questions about this? Okay. So next question. It's a bit strange maybe for some people because they didn't think about this before. First, I will tell you what's wrong answer. What? Wrong answer. Loop is faster than recursion. Actually, we already told you. Right? It's not sufficient to say loop is faster than recursion. That's a wrong answer. Depends on what's inside the loop. It's not because loop is faster than recursion by itself. It depends on what's inside the loop and what's inside recursion. So you cannot generalize and say loop is always faster than recursion. That's not a correct statement. Another wrong answer is heap is faster than recursion and stack.
Why heap?
Heap memory.
Where do you use heap there?
Malloc. We're asking you why the second one is faster than the first one. And some people say because heap memory is faster than recursion. Again, that's not true. Depends on how you access the memory. It's not true heap is always faster than stack. Okay? So the correct answer is redundant computation. Or if you can express that concept in some ways. So if you look at how we calculate Fibonacci using recursion, let's say fib phi is 4 plus 3. And for you to get 4, you have to do 3 plus 2. For you to get 3, you have to do 2 plus 1. And for you to get 3, you have to do notice that for you to get 53, you have to compute. You have to do some work here. And for you to do that, you have to do some work here. So you are doing the same work again and again. If the number is bigger, you'll do a lot more work, right? And similarly, you can think of F2 will be F1 plus Fibonacci 0. By the way, this is Italian, so that's the reason we pronounce chi, not ki. So if you look at Fibonacci number 2, you also need to do work, right? You have to do work. So you are computing the same thing over and over again. In contrast, the second one, you compute once, you remember it. So that's why the second method is faster. It's not true loop is always faster than recursion. It's not true heap memory is faster than static memory. The real reason is you are doing the same computation multiple times. And the second one, you remember what you did before and without doing it again. In fact, we'll start talking about recursion today. There are many problems they will be solved very naturally using recursion. And sometimes that means it's faster, sometimes simply means it's easier to write the solution that way. Okay, so it's just an example to show that in some cases recursion is slower. As I emphasized, the key is redundant computation. In some situation, you can use recursion without redundant computation, and it can be faster. So say recursion, compare recursion in the loop sounds like comparing hammer versus screwdriver. Sometimes you need hammer, sometimes you need screwdriver. It's not one is always better than the other. Depends on the application the problem you are solving. Any questions about the exam? Okay, it's pretty quiet. Because the exam is too easy?
Is it possible to ask, for example, if you didn't understand where you got points off, is it possible to ask?
Okay. Regrade by writing only to me. Do not talk to the TA. If you talk to the TA, this is what the TA will do. I told them, they'll take your exam, we will reject your regrade request. I don't want you to fight with TA. Okay, so you have to tell me, you have to write it down. And then, if you can write it down, there's a very good chance you get the point. If you cannot explain why you need regrading, you probably won't get it. So that's the reason I want you to write.
Do you regrade the whole exam or just the part that the student wants?
We may regrade the whole exam if we find that there's a mistake. Okay? Okay, within 2 weeks. So today is what? So 20. So next week will be 27. Then that would be what? So within 2 weeks. Okay. So March 6th.
How do you know that the student has not changed the answers?
You don't need to know how we know that. But if a student has changed the answer and get caught, first the student get F for sure. Second, the student will have record in the university. Third, if the student has done that multiple times, the student will be expelled from the university. I hope you are not thinking about that. There have been cases like that before, and for international students, you call your parents and say, can I buy an airplane ticket home? Right? Once you get expelled from the university, you lose student visa. You have to leave United States. I believe it's 30 days. Otherwise, you become illegal. So don't think about that. That actually happened before. Some international students cheated and get sent home. That's not a good idea. All right, any questions? I think I gave everybody as many points as I can. So
you graded it?
I graded.
Oh, okay.
But if I made a mistake, and sometimes I do, I'll be more than happy to give you more points if you deserve. Okay? All right, any more questions? Okay. There's no question. I'm going to continue discussing structures. Structure is one of the learning objectives. From Tuesday until the end of the semester, we'll see structures in every lecture. Why do we want structure? Structure is, we call programmer defined types. Because in many cases, almost any non-trivial program, you need to define some types for whatever you want to do. Maybe you want to create a type for students, you want to create a type for classroom, you want to create a type for bikes, cars, houses. So you can create types. Syntax is type defined structure. I can say integer x, I can say integer y. I can also have pointer, and here that means call it a vector. Maybe I have a name for the vector. If you create a vector, not create a vector object on the stack. So that means v.x, v.y, v.z, and v.name already have a space. However, the name is only a pointer, so you probably need to allocate space for. So you can write something like this: v.x. Okay, maybe I should write inside the function. I don't want to create global variable. As I said on Tuesday, a type is only a concept. There is no vector unless you create a vector. That will be called instantiation. So this also called you create an example of vector. Since that name is only a pointer, you have to do something like the following. And times your length, something like that, right? We just talked about that. Then sometime later, you need to say free. In terms of the memory, this is what the memory looks like. When you write vector v in your call stack, you have a v.x, v.y, v.z, and v.name. That's in your call stack. And when you say v.x equals 3, you put 3 here. v.name is only a pointer, so this one will store address. Once you say malloc, you create something in the heap. So let's say it's 100,000, so you put 100,000 there. This is the stack. Yes, please.
Can you show an example with an integer pointer and how we use
Integer
pointer in the structure?
I don't want to say
Like we're using character pointer name, right?
Mhm.
So can you give an example with using an integer pointer?
Sure. How would that be different then?
Like how do you access the values of it?
Okay, so I have a array.
No, just like one size of 1.
Oh, you mean this way?
No, like integer star a and then a just has a size of 1.
You mean this way, and then let me try to understand what you want to do.
Yeah, and this size of it.
Sure. You create a one element array,
Yeah.
and then here you can say is that what you're asking?
Yeah.
Okay. Of course, later on you need to say free, right?
Yeah.
You can create one element array. That's fine. Of course, you cannot do this, right?
Where did the array come from? What is it?
Where does it come from? Because you malloc. And why do you malloc? Because of it's a pointer. Okay?
Can I ask a question?
Yes, please.
So if you build a structure using a constructor, do you like, and if you malloc, do you malloc inside the constructor
Yes.
or outside?
Okay, so
If you construct it inside the constructor, how do you free that?
well, you need to hold on to that. Okay, so so suppose I want to say integer a, integer b, integer c, and then integer length 1. So I say vector v, okay, v dot x equal to a, v dot y equal to b, v dot z equal to c, and then v dot name. Is that what you're asking so far?
Yes. Where do you free?
You need to free later.
Okay, outside the function?
Yes.
Okay.
Okay, so you create an object inside. It will be on the call stack, but once you call it outside, let me put it here. Okay. Let's say 2,
Why did you
6,
create
4.
vector v inside? Okay. Never mind.
So what does v2 do? Now you have to understand call stack. When you call v2, the line here, in this line, this means the following, right? This line means actually means 2 lines. You agree with me?
Yes.
Okay, so when you say v2, you have space for v2.x, v2.y, v2.z, v2.name, v2.array. And when you put v2 in this line, v2 equals something, your variable address is going to be this address. Is the address of the first attribute. Then you have your call stack, so you have A, B, C, length 1, length 2. That's your argument. Inside you have your local variable. Since it's not a pointer, so you have v.x, v.y, v.z, v.name.
So if I do star v2, is it going to be same as doing v2.x?
Star v2, what do you mean?
Like if I want,
Now v2 is not a pointer, so you cannot do star v2.
Okay.
Then I create, since inside this function I have a v, so the call stack will look like the following, right? Because I have a local variable v. Then I assign A to here, B to there, and I allocate memory, so there will be memory space in heap. I have a location here, then maybe another memory space here. Inside the function. Then you say return v inside the function, and then you look at the address, so your compiler will copy that one by one. And then this will be copied here. One attribute at a time. You will copy each attribute for you. Since this variable is copied, that means you still have access to this memory. So this memory, this pointer now is here, and that pointer now is here. I missed a line. Does that answer your question?
And one more question.
Yes.
So is the address of is the address of v2 equal to v2 address of v2.x?
Correct.
Okay, that's one.
v2's address will be v2.x. Yes, that will be the same address. Address was first element, first attribute. If inside here, let's say you want to make a pointer, so consider a situation where you have vector v3. I should not say v2, v3. In that case, in your call stack, you don't have the whole thing here. You have only a pointer v3. v3 can only hold an address. So you have to say v3 equal to malloc and what that means is your v3 will point to heap memory and here you have a v3 x, v3 y, v3 z name and an array. v3 name is a pointer. So this will store an address. That means you have to say v3 malloc. Whatever length you want to have. And similarly for array.
Can we say star v3 is equal to vector construct?
No. Okay, so your question is star v3 equal to vector construct. Why that is not a problem?
I mean, if I return address of v, then okay, no, but it's on the call. No, never mind, I got it.
If after the function finishes, what's v?
Nothing.
Doesn't exist. So the address of v is meaningless. Does that make sense? Okay.
How about if we refer,
v3 doesn't have space. v3, without doing malloc, v3 has only space to store an address. You have an allocated memory, v3 has only space for an address. So if you do that, okay,
yeah.
because you don't have space. Does that make sense?
So we could create another constructor that returns.
You can create another constructor, allocate memory, yes. And if you want to, then later on you have to say free v3. You have to release memory in the reverse order. It's very important.
Why did you release one by one, not like just like release v2? When you release V2, you
Why do I release V2? V2 is not created by using malloc. You do need to release V2's name because inside here you do need to release V2.name. I should reverse the order. Because inside you have malloc. So here you have to release. If you look at this picture, V2's name and array refer to heap memory. So if you don't release, if you don't free, that heap memory will be leaked. But you cannot release V2 because V2 itself is on the call stack. You cannot release something from the call stack. You can only release something from the heap. So you need to say these two lines are necessary, but cannot say free V2 because V2 is not created by using malloc. Okay, any more questions?
Can you explain why freeing V3 does not free everything else?
That's the syntax of C. In C++, if you release an object, that object's destructor will call the destructor of the attribute, but you have to write that way. Java doesn't. In Java, you don't need to release memory because you have garbage collector, but you have to make the memory inaccessible. Okay, so I hope everyone can understand. Now another thing you can do is you can create a corresponding function we call a destructor. And here you say free v.name and free I should reverse the order. And here, instead of doing this, you replace these two lines by or you call destructor and release the memory there. The advantage of writing a destructor is you can write a constructor and write destructor and make it look symmetric. Then you don't have to remember you need to free two things. You just call destructor. As I mentioned on Tuesday, it's very likely sometime in the future somebody will tell you, can you add one more attribute in your structure? It's almost guaranteed to happen in some case throughout your career. Some people will ask you to add more things. If you use a destructor, there's only one place you need to change. Only one place you need to change for constructor, that's a constructor. Only one place to change for destructor. And you will not forget, because that's only one place you need to change. If you do this way, now you have two, later on you have three. Sooner or later you will forget, and you will make a mistake. So you should use destructor. And if you look at destructor and constructor, they are symmetric. You have a memory allocation in constructor, you have memory release in destructor.
So how do you use the structure for the vector, pointer V3?
In that case, you need to write another destructor. So you will say vector you have all your argument. Okay. I should say 2.
Why can't we pass star V3 to the old destructor?
Why can you not pass star V3? Because V3 points to heap memory.
Yeah, but the values in the heap could be copied into vector V.
But okay, so your question is, can I pass
Star V3.
is that your question?
Yeah.
Okay. Do you remember that destructor did not release?
Yeah, but we can free V3 later.
Okay, what did I just say? You create mistakes because you have to remember to free V3
No,
also.
I
So the better solution is to write, if you want to, a constructor for non-pointer and a constructor for pointer. Or you make out your mind, you always use pointer, or make out your mind, you always use non-pointer. Once you have to keep track of consistency, you make mistakes.
And my question is like, can that call replace free V3 of array and V3 of
Yes.
array?
Yes,
Can, right?
you can do that, but you still need to remember this line.
Yeah. Sorry.
But that increases the chance of mistakes. Does that make sense? Okay. Any more questions about structures?
Well, you need to remember the last one you said?
If you use this line here,
Okay.
that line only releases the memory
Of array and name.
for array and name. Because the structure has only array and name. Therefore, you have to remember this to add this line. And every time you have to remember something, you increase the chance of mistakes. Right? Yes, please.
I have a question that when we do our homework and we try to use a structure, we define in a new head file and include it in our .c file.
Correct.
And how are we supposed to submit our C file? Because do we need to submit the head file together or?
I thought header file is given to you, right?
Yeah.
So
Header
the
file
structure-
is given to you.
So the structures are given as well?
Yes. Isn't that true?
I don't know.
Yes.
Okay.
Yeah.
Thank you.
Good.
Alright, so there's one more piece of information you need for the assignment. Is how to read and write the whole structure from a file. There are two functions, they are very, very nice, called fread. So let me read the fread function. So fread will read data. The first one is a pointer. And then you will read so many bytes. You may read multiple, it may be an array. So this is what you can do. Suppose I get rid of all the free and so on. Okay. Let me just get rid of this. Is that okay? Everybody needs that? Oh, let me write another function. Okay. Let's say read image. So I'm going to say vector. No, I'm going to change that. I'm going to say type define structure. Now this is different from your assignment. I'm just going to give you the concept. Your input image will have two parts. The first part is called the header or the metadata. So first you'll say F open. You open it for read, and then you obviously have to check whether your file pointer, you F open succeed or fail. Okay. Otherwise here you will create, let's say, image header. Then you'll say fread. You give the address. Let me see what's the second argument. Second argument is the size. So here you'll say size of there's only one image, one header. So this one will read all the attributes because tells GCC the size of an object. You may have additional things. For example, you have maybe integer, color, depth. If your file was written correctly, then you will be able to read all the attributes at once using fread.
Can you explain what does fread does again?
Every will take
One
an
line.
address of an object, you need to have a memory already allocated. If you don't have memory, you have to allocate memory. So another way to do this is you will say image header. You need to allocate memory. And then you can say fread. In that case, you don't have point, you don't have an ampersand there. Of course, sometime later, you need to free. Fread will look at your size. The first argument is the memory location for you to store data. As I already said, you have to make sure you have space there to store the data. So either you create an object like image header, or you create a pointer, but you have to allocate memory, like image header 2. Then the second argument says how many bytes you need to read from the header. GCC will calculate that for you. So this is convenient because I already said many times, your structure will change for many, many reasons. And when your structure changes, you recompile your program, GCC will calculate how many bytes to read. You don't have to do that by hand.
What is one?
Once right now says I'm going to read just one header. After you finish reading this, you may have an image like this.
Like a constructor?
You can create a constructor. You may say this image header. You may say this will be pixels. So you may read the header, and based on the header, you will create an image.
So after doing the first, you can image header dot fread. So it's like a constructor.
Let me finish this one and I explain.
What if you have like pointers inside your structure? How does that fread handle that?
You have to separate. That's what I'm doing right now. Okay, so let me go up here and explain what I'm doing. Let me get rid of that, just to make it simpler. Okay. Suppose you read the header here. Okay, you read the header. As I said, you have two ways. Do only one. Otherwise, you will read the same size twice. Every time you read from the file, you move forward in a file location. So if you can only read this one or this one. Don't do twice. Okay. Is that clear? If reading only one image, you should have only one header. So either you do this way or you do this way, but not both. Okay? Is that clear? So I'm going to delete this one, okay, to prevent confusion. So suppose I read the header. After I read the header, I know the width and height because that's defined in my structure. Then I want to read the image. Image contains pixels. Then based on how many width and height you have, you will do something like the following. You allocate space for the pixels. Then you can read. So to answer the question of what's the first third argument? Now you have so many pixels.
can't directly read the IMG over here. You have to read pixel.
No, you cannot read IMG directly. Because it's a pointer.
So
If you-
IMG has other values that are non-pointer values, then how would I read those?
If you have non-pointer variables, for example, you can say if that's the case, okay, then I don't need a header. Then you can say this one you're reading two integers, width and height, right? Then here you will say this one will become does that make sense to you?
And does the order that I read have to be the same as how it is in the structure? Like
No, it will automatically read based on the structure of in the definition of the
in
structure.
my structure, if I declare pixels first and then I do width and height, do I have to read
You have to follow the order, correct?
So can I say that fread is basically a constructor?
fread allows you to read a big chunk of data at once, and that chunk of data may include multiple attributes. In this case, I'm reading both width and height at once, because in the second argument, I say size of integer times 2.
What if you just size of integer? What,
Then you only read width.
what if you only want the height?
You cannot.
So
You have to.
the next-
Then you have to skip one. Because remember, file is a string model. You have to move forward. You can either you read one integer, throw it away. You read one integer, put it width, throw it away, or you have to do fseek. Does that make sense? Because once you start open the file, you have a position at the beginning of the file. You read, that moves forward. If you don't read, that stays there. Then you can do fseek, that allows you to move forward.
So you in your file you have to keep you have to give a correct order. So
Correct. Now, however, this is correct. You need to give correct order because of a pointer. If you don't have a pointer, the compiler will take care of the order. Of course, fread and fwrite, you have to write the file in the correct order,
yeah.
right? So if fread and fwrite are reversed. So if this is the way you call fwrite, and then later on you reverse the order and call fread, that will be a problem. Does that make sense? So fread and fwrite have to they correspond to each other, and you cannot reorder the attributes.
Right, you know.
Here we don't. I'm not showing fwrite, but fwrite is the reverse of fread. Fwrite allows you to write a whole chunk of data at once.
Please scroll down.
Sure. So suppose you have after finish write reading, you can say fwrite. It's the same syntax, but now you have to do open. You have to open for write. And then this will be
So what?
So what does
You're not-
it do? It reads. I mean, sorry.
this one.
You're not ready
Read.
to do file.
Actually, I probably should read. I read, and I write to another file. Oh, I should have a file name too.
Right, so, okay, so
Yeah,
now that
otherwise
writes- so you'd have to pass into the function another file name,
you need to pass the file another file name. Right?
right, to that, okay, gotcha.
Yes.
Why is the size of pixel equal to the size of the char character?
Oh, because we define each pixel as character.
Yeah, but why?
Depends on the image type. Most image type use a bit for a color. That's pretty standard. You may have heard true color. That means 16 million different colors. How to get 16 million? You get 24 bytes. What's 24 bytes? Red, blue, green. Each color has 8 bits. That's a very common color model. That's not the only color model, but that's a very common color model. RGB, you may have heard RGB, right? Red, blue, green, and each color has 8 bits. That gives you 24 bits. That gives you 16 million colors. In some some image types, they have RGBA. A means transparency. That means alpha. And that's transparency. Sometimes you can superimpose an image on another one because one image is not opaque. It has transparency. So that in that case, that image per pixel will have 4 bytes. Yes.
When you take an image point IMG, is that by choice or do you have to make that?
Which slide?
Over here. Image point IMG.
This one?
Yeah. Have you done that by choice or do you have to make it one?
It's a standard question. Do you want a pointer? Do you want right? If you have a pointer, it's more flexible. You can pass out the wrong function. If you don't have a pointer, once that function is gone, that's gone.
And in case of read image, I have to return IMG.
Yes, if you return. Yes. Okay. All right. Any more questions? Good luck. Do you want to warm weather?